Hey everybody, this is Larry. This is day 9 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prompt. Today no updates. I am just tired still, just even though I rested all day. Yesterday I guess I ran pretty hard, but this is peak week. This is my only day off this peak week, resting, running. So let's get let's finish this problem and I'll get back to the couch and rest up. All right, today we have 3494. Find the minimum amount of time to brew potions. All right, so you have skill and mana, length S and M. Say S and M. Okay, whatever. In the laboratory, they brew them. Some wizards brew potions. Okay, so they're way of manners and they're all potion. Okay, so each potion has a mana capacity of that must pass through all the wizards to the country to be brewed properly. Okay. Maybe. I don't know. Alright, so let's just take a look at the example. I don't even know anymore. The potion must be passed to the next wizard immediately after the current time must be synchronized so that each exactly when it arrives. Okay, what does that mean? Okay, let's just take a look at an example. Okay, so skill 1, so then the potion 0 is done by 5. Okay, and then why do they just not oh, it starts at 0, so it's 5. Okay. What? And this is not a good day for me to need to read, what? Okay, so 5142, so it starts at 0, ends at 5. Okay. And then this one ends at 0, starts at 30. What? What was done by mean? The example does not make it clearer at all. Where does the 5 go? Okay. Oh, because they have different scale. Okay, so it's 25. Okay. So maybe I... Okay. So then the potion one will be done this. And on the second potion, we start at 52. Why 52? So that it can be done at 53. And then the 58, 60, 64, right? Okay. So I think I honestly still not quite sure. And this is only a medium. Wow, this is a very difficult to read problem. But what I am going to try to do is to visualize it. Right? Is to draw something out. Okay, there we go. Okay, so the idea then is that, let me make sure that I have it on screen. Yep, okay. The idea is that, okay, so let's say you have mana is equal to 5142, right? So these are the potions, and then skill is equal to 1524. So what that means is that given an XY axis, right? The first line, change the color real quick, will be something like how do I want to do it? 5. That doesn't look like a 5 though. Like 5, 1. No. We want to draw the first potion the other way. Okay. So then you have 1. You have 1, 5, 2. Okay. 1, 5, 2, 4. Something like that. Maybe this is something that we can. I wonder if there's a tool online. Give me a second to just like plot points and draw lines. So I don't have to do it manually because I don't know. I feel like I just have a dumb visualization. Draw points on a graph online. Obviously. Why is my computer so slow? 5 points. All right, I just. Okay, I mean that's fine, but I just want to draw. Maybe I could just draw, hang on, sorry, for technical difficulties. Graph plot, maybe that's a little bit better. I just draw it manually. Sorry, friends. I don't know why my computer's so slow though. That's also why, like, yeah. Technical difficulties, but maybe I should restart the computer first. Oh well. Okay, let me right quick. All right, where's my drawing thing? All right, so does this paste? Okay, there you go. Okay, I mean I don't know, it's good enough, right? All right, can you see it? Okay. So then now, ignore the Brew point for a second, because I think that's just from where I copied it from. Okay, so now you have 1, 1, right? So this is 1, and then you have 5 on the scale, so it's going to look like this, and then 2, and then 4. So okay, it still kind of goes outbound. Okay, this one could be a little bit better though. So 12, so that's 10, 11, 12, something like this, right? Okay. So we have something like this, and then the next one. Wait, did I mess that up? Oh no, this is for the first potion. Actually, I kind of messed this up. Okay. This one's a little bit annoying to visualize then, right? Because for the potion 5, then actually it's not 1, 5, 2, 4. I mean it kind of is, right? But you have to multiply everything by 5, right? So you have 1. Let's just redraw that. 2, 4. So then now you have to kind of scale that friend by 5, right? Okay. And then for the next potion, it is actually just this, without the flattening. And then we want to synchronize it. How do we want to synchronize it? To some synchronization thing? You want to synchronize it so that each wizard begins working on the potion exactly when it arrives. So basically, is it always possible? Oh, no, I see. So that it just has to be free at that time, right? So, okay, so let's just say, I don't know, this is a really weird problem. I mean, I get what they're trying to go for, maybe. So this is the 5, but it's just so hard because then the next one is like 25, so the visualization is not very useful, right? Just because they make it so. But the idea is that all right, let's actually do another one. And maybe that example is a little bit bad. I could do something where the example 2, which is 1, 1, 1. So then, okay, maybe that's too simple, but let's at least try to visualize a little bit, right? So you have 1, 1, 1, right? So then this is going to be first potion, and the second potion, and the third potion, right? So then now we're just trying to make it so that these don't overlap. Is that it? Okay, maybe, I don't know. Let's do the example 3, which is the skill is equal to 1, 2, 3, 4, and then mana is equal to 1 and 2, right? So then now it's going to look like 1, 2, 3, 4, right? For the potion 1. And then potion 2 is going to look like this. 1, 2, 3, which is 11 already. So something like that, right? I don't know. Yeah, and the idea here is that the Brew line has to move up so that so basically you're trying to make it so that it does at no points do they intersect, right? And because everything is going to be a constant of each other, It's just okay. So maybe that is a better way of saying it. I don't know. Right. Sorry that I'm taking so long on this one. How am I? Because I'm still trying to actually just understand what it's asking. And I'm not even. But basically, you have some lines, right? Oops. So you have some lines, and because P, the potion, P is always going to be a multiple of this, right? So that's the idea. So then now you're just trying to make it so that it doesn't intersect. So then now, my question is, what I'm wondering is that like, do you, I'm trying to think whether you would just binary search. I mean, I don't know if that's a hint from like yesterday, kind of, but basically you have, let's just say for all purposes, all of this is a one. So then now you have another one that looks exactly the same, right? But you want it to be none of the points are touching at all. And to do that, then now the delta of each point has to be at least one, right? And of course, we made it so that, or the examples that we were given, or that I've been doing, right? You know, the potions, other than the first one, or the potions are kind of like increasing. But you can imagine that the potions could have like the first one could be 3, and then the second one could be 1. So then now the first one's gonna be like much crazier, but then now the second one goes like, you know, maybe just okay, you know, maybe the first one. All right, I'm gonna start here for a second. Like you could say every 3, right? So let's just say the potions are 3, 3, 3 or whatever. So now it's gonna be 3, 3, 3, 3, and then now your next point, you actually want, you get something like 1, 1, 1, 1, 1, and then now you're trying to elevate these points such that at every point it is greater than the orange, right? So you want the second line to always be above the orange line, and that's it. Yeah, I mean, I don't think is there binary search? I don't think so, right? You just kind of in that case, you just do a loop. Let's see, it's 5,000, so just for 5,000 squares should be okay. So you just kind of do a loop, find the delta, and then just raise it by that delta, right? Man, this took a long time even just to understand. So I don't even know if I'm going to explain it well, because I don't know that I understand it well enough, to be honest, right? But let's try it, right? So then now, but I think we have the visualization at least, in that we just want to get lines that do not intersect, so that because each wizard cannot work on 2 potions at the same time. I think that's the general idea. So then now the first one, maybe we just how do we word it, right? So maybe T is equal to minus sub I for no minus sub 0 times S for S in skill, right? So that's basically the first time. No, that's not true. That's not true. I mean, it's the cost, but not the time. It's the time for that wizard, but not the time in which it is done. So we have to kind of update it, the time it's done. Okay, fine. So maybe we just use this, right? Maybe that's even easier. Nope, not for skill the wizard. Skill is the wizard, right? This is the skill of the wizard. Okay. Right, and then now we have 4 M in mana, right? And then now we go for each skill, right? Let's go S, right? And then now we know that at every point it has to be bigger than the last number, which we'll put it on T, right? So then now maybe let's just say delta is going to be equal to T sub. And this is a summation thing, so it's not just this. I have to remember. Okay, so then now. Okay, so we just started at 0, right? So then we can calculate the delta. Okay, fine. So then maybe current is equal to 0, right? Then now current we added by the skill times the manner, right? And then now we compare it to T sub I, right? So delta is equal to 0. So then this is the start, right? Because this is start point and an end point. The start point, which is why give me a second, I have to stretch. Okay. Yeah, because for 4 visits, you also gotta keep in mind the start time. All right, does that matter? I guess we could just say the start time is 0, and which is what we're doing here, and then just kind of do the math that way. Okay, fine. So then now, delta, you go max delta current minus, is that or delay? I think maybe this is fine, right? So T of I, if I could type it correctly, right? And then now it means that we need to raise this line by either at least delta or delta plus 1. Because yeah, I think it's delta plus 1, because that means that your one, so the line doesn't cross. If it's exactly delta, then that means that you raise it by that much so that it crosses exactly, right? So okay, so that means that what are we supposed to return? 110 is the time it is done. Okay, so raise it by delta plus 1, right? So that means that, yeah, maybe we just do the loop again, right? So then now the start is going to be delta. So then we have T sub I increment by delta. Is that right? I mean, kind of, but not really. So now the starting time is going to be delta plus 1. Whoops. Right? And then this is just S times M. Or actually not even plus, it just is, you go to current plus this. So it's the delta plus this. And then we're Gucci maybe? I don't know. And then just like T, right? Let's just print T real quick so that we could visualize it. I don't know that this is quite sensible. And definitely it's not that. It should not go back to 0. I need to prefix something, but even the 66 is not quite right, right? So a lot of things are missed. A missed? A foot? Why is it though? Okay, so let's say we just have 0, so then now current. Let's just print delta real quick. Delta is 60, is that right? Oh yeah. Okay, I think I got it the other way. That's why. Okay, because this one should actually be 0, right? So we start at 0. Oh, in that case, no, delta is well. And this is not quite right. In that it needs to be prefix sum, which is why the numbers are small. This is why this is right. Okay, so this is maybe at, I don't know if it's delta or delta plus 1, because if it's delta plus 1, then it's off by 1 for some reason. maybe it doesn't for this first one. I don't know. Well, let's just run it real quick, right? If it's off by 1 is easier to fix anyway. Okay, so here that's the first line, but clearly it. Oh, no. Why is this? Delta is 36. Oh, is this because I do it current is equal to delta plus 1, which is not right. What it needs to be is. What does it need to be? I don't know that this is off by 36 anyway, so maybe I'm just wrong. Because clearly there's none of this is 36 times or plus. I mean, that's 48. This is 30, oh no, this is 28. What is going on with this problem? I mean, I think I get the idea right, but maybe my math is just really wrong, right? Because basically now this is saying that if we start at we start at 0, this is the delta. And the second portion has a scale of 1, so that means that 36 why is that 36? It is under by Wait, why is it minus delta? Okay, maybe that's why then. It's just that the first row delta is 0. I am just making silly mistakes. Okay. I mean, you could see that we're off by 1 somewhere, but at least for the first few. But it looks close-ish, maybe? Maybe not. Because 52, 72 doesn't really make sense, right? Well, 51, we're off by a little, we're off by 2. Some of it is because we're adding plus 1, maybe we shouldn't, I don't know. Let's try without. But this 51 doesn't make sense, so I don't know. I don't know, that's 51 assuming that it is starting at 50. Should it start at 50? Well, no, but this is because this is off by 1, so Alright, let's do it without. Then now this is maybe a little bit better. In that, well, I mean, see, this is what happens is that now we're saying that it's going to end at 60, which is fine. But yeah, actually, I mean, this is kind of right? If we're able to kind of say that they all meet at a point, then they meet at 93, which is But I think I'm wrong here, because even with the plus 1, I think we're wrong, because I'm only looking at the starting time, and this gives me the next starting time. But what this is saying is that if it's done at 5. No, actually, maybe this is right. No, I mean, this is definitely not right, because it means that I think my math is a little off, or my understanding is a little off. This is a very weird problem. I still don't think I understand it, because that means, I mean, my visualization is wrong, is what I'm saying, because at this 60, this is matching the 60, which is kind of what we want, but not actually. Well, it's what I thought I wanted, but it's not, right? Because it means that when this is done at 60, that means that with the 3, this number can only be 60, right? So it's actually not minus current. How are we saying it? Okay, so this is the previous time it is done. It's something like I minus 1 or something. Maybe we need to do like a plus 1 type thing. Yeah. Maybe something like this. I don't know. Okay, that's clearly not right, because we set it here. Now it's just really not right. I mean, I think that's the same thing, but I think the idea here is a little bit better, but it is definitely more wrong. Okay, let's undo some of this. All right, I think it's time to step back a second, right? But basically, it is saying that okay, so the current is is actually I plus 1, not I minus 1, I think. But then we set, I think this is more right. Okay, I mean the first line is correct, yay. But the second, that means that the delta is 48, which is not quite right for the next one, maybe. Because then now, well, 5, this current is, no, you want to start, so maybe someone like this, I don't know. Oh wow, I mean honestly I thought I had more work to do, but this somehow worked out. Now, I don't know if it's lucky, so we're just gonna YOLO submit, and then we'll figure it out. I think I misunderstood some parts of this for sure, right? And this is n times m or s times p, which 5,000 squares should be fast enough, but if it's not, then Leetcode sucks. That's my story and I'm sticking to it. Looks okay. 21:18 streak. Let's make it slightly faster. 13 seconds is ridiculous. And the easiest way is to do, you know, if you always wonder why I write it this way, then you know, this is why. And it's just writing the max so that it doesn't, it's a little bit faster max function. Right. But I think I did the visualization wrong. I think that's the TLDR. Yeah, and you can see that this saved it 30 seconds. Let's get back to visualization real quick, with the correct visualization. I was saying that we're trying to do this thing where like the lines don't intersect, which is strictly true, but not sufficient, right? What I needed to do is, let me, oh, did I close that window? Okay, fine. Let me try to find another, what's it, graph plot? It is a ridiculous problem to understand. It is for me. I don't know. Alright. Alright, what is this for? Ants? Alright, so I kind of made a mistake there, honestly. I was saying that, you know, let's say you have some lines, right? But actually, it's not even that. It is that, you know, let's just say we have a line, right? That is like, you know, 1, 2, 1, 2, right? And then the next one, let's just say is even on top, the same multiplier, right? So the thing is that, and I was just assuming that I could like, okay, given this one, I can move this one up, and then now there's no intersection, right? 1, 2, right? I mean, okay, I drew it so that there's intersection because they're not straight lines, but you know, there's no actual intersection. But that's not sufficient. I misread this one, or I misunderstood it in any case. I don't think I misread it. Instead of lifting this only up by 1, actually, it's just so coincidental that for the problem, this 1 is also to this point, right? So then this goes to here. Then the next requirement is that this point is actually at 2. So that means that it has to be at least here, right? And this one's at 1. Yeah, maybe 1. So it has to be at least here. And then so forth. And that's basically like, these are the constraints for the line that we're trying to fit. And then after that, you can find the deltas behind what we need, how far do we need the deltas to be, and we are good. I wish I could do a little bit more on the different scales. It's a little bit tricky just because scale just goes really quickly, right? Let's try again here. I'm going to start at the bottom of the line so that it, I mean, pretend that's 0, 0, right? So you have, okay, that's not right. You have like, you know, 1, 2, 1, 2, right? Right. 1, 2, 1, 2. And then now let's say you want to multiply. No, the other way around is a little bit better. Okay, fine. So let's just say you have 1, 2, 1, 2, right? And then the first multiplier is going to be, say, 2. So then now you have effectively 2, 4, 2, 4. Oh, geez. I just want 4, 2, 4, 2, right? Something like that. And then let's say that means that, what does this mean? That means that this is done. So then that means that this is your constraint. 4, you have this is your constraint, this is your constraint, and this is your constraint, right? And then next, let's say the next one, we just do the scale is equal to 1, right? So then now you have to fit this line 1, 2, 1, 2. I did the last one wrong. Okay, fine. Oh, geez. 1, 2, 1, 2, right? Except for that, now we're calculating the gaps between this point here to this point, because no, the other way around. We have to calculate this point to this point, right? Wait. Yeah. No, this is right. You have to calculate this point to this point. Ooh. Well, I mean, that one was right, but not straight at all. Right? So to this point, because that's the constraint. So that's what we do, is that we look at each of these deltas, right? To figure out the maximum of them. And then the maximum of them, we just kind of push the line up. So then now, that means that when the last worker is starting, which is at this point, it is after it finishes the last job, which is at this point. And that's kind of the idea. The visualization is terrible because, you know, the scale is just too big for me to draw very cleanly. But hopefully that makes sense. Yeah. And that's it. I mean, this is going to be M times S, right? Just because, you know, you see the for loops. I do this twice. First time to calculate the delta, and then the second time to redo the math, right? Maybe we'll do it faster. I don't know. But that's all I have. Let me know what you think. I did this. Wow, this was this year. What did I do that time? I mean, I still took it twice. I think this is basically probably the same idea. Except I did it backwards for some reason. Not sure. You should watch that video. It wasn't that long ago, if that makes sense. But yeah, but today the code seems cleaner, I think, to understand. Though the problem is still annoying to read. Like, it is. I guess this idea is not that hard for it to be a hard, but the reading comprehension problem is very hard if you ask me. So yeah, I don't know. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.